Welcome to video 3.3.1. Some of the last videos in this is the last lesson in equilibrium. So let's get started. First, let's remind ourselves what Le Chatelier's principle is. If you don't remember Le Chatelier's principle from your first chemistry class, it's definitely worth pausing this video, looking that up, and then coming back. So it's really important that you understand what Le Chatelier's principle is, because we're not going to go over it in detail in this class. That said, as a quick review, Le Chatelier's principle, just really quick refresher, if you take some of this away, so if you take some of your reactant away, the reaction is going to shift to produce more of that reactant to replace what you took. So we say the reaction shifts to the left or toward reactants. Same thing here, if you took away one of these products, your reaction is going to shift to the right to create more of these products. If you added more of this, if you added more reactant, you're going to shift to make more products. And if you're going to add more product, you're going to shift to create more reactant. Okay, so that said, that was a really quick just refresher to remind yourself what Le Chatelier's principle is. But if you haven't learned it yet, please, please, please pause this video and go look up what that is first. Okay, let's talk about Le Chatelier's principle and its relationship to KSP, or solubility of these sparingly soluble salts. So our first example. Calculate the molar solubility of calcium hydroxide when the salt is placed in pure water, and then is a solution acidic or basic, and explain. So first, let's go ahead and write our dissociation equation that we have for our salt. So here we have our calcium hydroxide, and that's a solid, and that's in equilibrium. I'm just copying this down with calcium ions and our two hydroxide ions. It's our balanced equation. Initial, change, ending. We don't count solids. So our calcium, we start with none, start with no hydroxide, plus S, plus 2S for this 2, carry it down. And then ending, you have S and 2S. So same thing we've been doing before. KSP equals the concentration of our calcium. So remember, we don't care about our solids in our KSP equation. So our calcium 2 plus times the concentration of hydroxide squared for that 2. Plugging in the numbers, or the variables rather, that we got here, and our KSP that is given to us here. So KSP is 1.3 times 10 to the 6, or sorry, negative 6, equals, let's see, the calcium was S times 2S squared. Solving for S, you get S equals 6.9 times 10 to the negative 3 molar. Okay, so that's our molar solubility for our calcium hydroxide, and that's in pure water. So is this basic or is this acidic? Well, that should be a simple way to tell. Anything that produces hydroxides in water is going to be basic. Anything that produces hydrogen ions in water, on the other hand, will be acidic. So here we are producing hydroxides. This is basic. So it's basic because hydroxide is released. Now let's suppose some acid were added to that saturated solution of calcium hydroxide. So we have this solution going on, and we write some acid. So let's see what happens, what secondary reaction is going to take place. So an acid produces H plus in solution, so we have H plus. And that hydrogen ion is going to specifically react with hydroxide. So plus attracts minus, so plus OH minus, aqueous. And that is going to form H2O, liquid. So that would be our side reaction that takes place. Would the solubility of calcium hydroxide increase or decrease? Explain the change in solubility using Le Chatelier's principle. Well, what's going to happen here is when you add an acid, this OH minus, this hydroxide, is going to get taken away from solution. So you're going to take that hydroxide, combine it with with hydrogen ions, and form water. So essentially you're taking this hydroxide away from the solution. When you take this away, the reaction is going to shift this way. So it's going to shift toward more products, or more ions. That means this is going to break up more to form more ions to replace what was lost. So again, saying that again, the H plus reacts with the OH minus here, and that's going to form water. It's going to take away these hydroxides. So your reaction here is going to shift to the right. It's going to shift toward products. And that means that you're going to break up more of this salt. If you break up more of that salt, now suddenly that means that that salt is more soluble because it's breaking up more. So overall then, if you add the acid, your solubility is going to increase. Solubility increases. Adding acid will remove hydroxide from solution. So the reaction will shift to the right to restore equilibrium. Okay, so if this doesn't make sense, if this doesn't make sense to you, the shifting to the right and why it shifts to the right, make sure you go and understand Le Chatelier's principle. So again, if you're not sure, if you didn't learn Le Chatelier's principle, don't try to go through this lesson and learn it here. Go look up Le Chatelier's principle. Okay guys, next. So notice that the dissolved ion hydroxide reacts with added hydrogen ions in a side reaction. That was that reaction here. In general, when there is a substance that reacts with a dissolved ion, the solubility of the salt will, just like we saw here, increase. And that's because if something's reacting with your side ions here, you're going to form more of those ions by breaking up your salt and thus increasing your solubility. Now, suppose calcium hydroxide were placed in a basic solution. Would the solubility of calcium hydroxide increase or decrease? Explain a change using Le Chatelier's principle. So if you were to add more of this, what would happen? I'd like you to please pause the video, write whether or not solubility increases or decreases, and the reason. Go ahead. Okay, so here, if we add more hydroxides, we are going to increase the amount of ions on this side. Therefore, the reaction is going to shift to the left to create more solid, decreasing solubility. So if you add more hydroxide, again, you're going to shift the reaction left toward the reactants, and you're going to decrease solubility because you're basically just going to form more solid salts there. So solubility decreases. Adding a base will increase the hydroxide in solution. So the reaction will shift to the left. Forming more precipitate. Notice that when an ion of the salt is already present in the solution, the solubility of the salt decreases. So if you have an ion that's already present, like here, and you add more of it, your solubility is going to decrease. In a solubility equilibrium problem, the equilibrium can be affected by adding or removing ions in the solution. This will affect the solubility of the compound as we saw above, so it can either increase or decrease. If a solution has the same ion, like we saw here, as one of the ions in the dissolving compound, we call that a common ion effect. And we say common ion effect because the ions are in common. And the solubility of the compound is the common ion effect. Sorry, that's the common ion. This is the common ion effect. And the common ion effect acts to decrease the solubility or increase the solubility depending on what you add into your solution. We are going to take a closer look at the common ion effect in the next video, but that is the end of video 3.3.1.